In this video, I'm going to look at the information entropy per letter calculation for the poem by Robert Ffrost, Stopping by the Woods on a Snowy Evening. So let me just talk about first a bit. Bit is the sort of smallest unit of information. We often talk about it as a 1 or a 0, or the answer to a true, false, or yes, no question. So it can, a single bit, 1 bit, can tell you, have you distinguish between 2 states. So there's yes and no, or 0 and 1, and then the bit can be in those 2. 1 bit can be in 2 states. And then the general relationship is, I'm going to show 1, 2, 3. Let's go up to 10. If there are 2 bits, then they can be in 4 states: 2 zeros, 2 ones, a 0 and a 1, and a 1 and a 0. Where that is, the relationship is 2 raised to the number of bits. That's the number of states. So for 2 bits, it was 4. Then for 3 bits, it's 8, and so on and up. And if I were to have, just to invert the relationship, if I had the states and wanted to get back to bits, that's a log base 2 relationship. So I can get back to bits if I know the number of states. Excel lets me do different base logs. So I'm taking the log of the number of states in base 2. And that's just the inverse of what we just did. Okay. So what I want to do then is talk about the number of states in letters in English. So there are 26 letters in the alphabet. And if I consider them states, then how many bits are in those states? So that's 4.7. So there are about 4.7 bits in letters, in the characters that we use in the alphabet. And we're not going to worry about capital and small. That would add another bit. Okay, so 4.7 is the capacity of the alphabet to convey information per letter, but we don't maximize, we don't reach that capacity because we don't use the letters. Some letters are common, like E, and other letters are uncommon, maybe Q or J or Z. And so that makes that the situation that we're not using this full capacity to convey information with our letters. So I want to do the calculation to show how much, how many bits are we using per letter. So I'm going to show that calculation here. So I'm just going to, and that relates to the sort of frequency or the probability that we're going to use a letter. So that's the first thing I'm going to do, is calculate the frequency of various letters. So I'm going to start with A, B here, highlight both. Hopefully Excel will pick up the pattern. No, it picked up the pattern A, B. And if I do A, B, C, will it? No, it'll do A, B, C, A, B, C. Oh, well. So let me just say equals what's above plus 1. And doesn't like that either. So E, F, G, H, I, J, K, L, M, N, O, P, Q, S, T, U, V, W, X, Y, Z. I missed one. A, B, C, D, E. I missed F. Did not want to fail, I guess. Insert, there we go. F. GHIJKLMNOPQRSTUVWXYZ. Fine. Okay, so that's the letter, and I want to find the frequency within some text. As I say, I'm using Stopping by the Woods on a Snowy Evening. So this particular poem, I'm calculating the frequency in it, and I'm going to use Excel. I'm going to use Word. I'm going to use Edit, Replace, and I'm just going to go through the alphabet. I'm going to find an A, and I'm going to replace it with nothing. And then when I say replace all, it's going to tell me, so I'm going to get rid of the letters by replacing it with nothing, but it's also going to tell me how many replacements it did. So I'll mark that as the frequency. That was 25. Now we'll move on to B, 8, C, just one C. 16 Ds. E, there's usually a lot of E's. 69. F's. 10 F's. G. 9 G's. H. There were 30 H's. I. 31 I's. J. No J's. K. There were 11. L. 19. M. 9. It's a little tedious. 27 N's. O. 46. Oops, that was O again. P. 12 P's. Oops. Over there. I forgot to record. It was 46. I'm just going to say I was right. Q. 1Q. R. 20. S. 42. T. 37. U. 9. V. 6. W. 17. X. There were no X's. Y's. 9 Y's. And Z. 1 Z. Okay. And we should have nothing but punctuation left. So that was true. So we got all the letters. All right. So one thing we'll do is we'll make a histogram of this. So let me open my Excel a little larger here and insert, and I won't choose histogram because I've already done the counting. So I'm just going to make a column chart here, and this will be the distribution, frequency distribution for Frost poem. Okay, so we see high frequencies for the vowels and certain common letters and very small things, and there are no J's and no X's and only one C and one Z. Okay, so now we want to turn this into from a frequency calculation to an entropy, and so we have to turn our frequencies into probabilities, which we will do by adding up the total number of letters, 465, and then dividing our frequencies by that 465. And I want to copy my formula down, and I don't want the 28, my sum, to change, so I gave it a $sign. Copying that down. And then if I take the sum over, that should be 1. All my probabilities should be 1. So that was the frequencies. These are the probabilities. Okay, now I want to do the entropy here. And that formula is minus the probability times the base 2 logarithm of the probability. But Excel is going to blow up if we try to put a 0 into that formula. So the first thing we're going to do so that we can write a formula and copy it down is protect if there's a 0 for the probability. So if the probability is equal to 0, then I'm just going to give myself a 0. And otherwise, I'm going to give myself minus probability times the log of the probability base 2. And then that's the close of the log. And then let me close the if. Okay. So let's see how we do. So here were the 0. So I've protected myself with the if, asking if the probability is 0, just give myself a 0, and otherwise do this calculation. Negative the probability, which was in column C, times the log of the probability, and it's a base 2 log. And then I'm going to add those up. And that is then the information entropy, or the number of bits we are conveying per letter, pretty much in normal English, but in particular in this Robert Frost poem. So we don't have the full capacity of 4.7, but because of using the certain letters like E very frequently and certain letters like X and J infrequently, we're not at our information capacity, but we're not too far off of it. So we're using about 4.11 bits per letter. Okay, thank you. That's what I wanted to show you in this calculation.